Hello everyone, my name is Aditya Tiwari, Assistant Professor, CSVTU, Bhilai. In today's tutorial, we discuss about searching. Searching is the process of finding some particular element in the list. If the element is present in the list, then the process is called as successful. Suppose we having a list, suppose you go the contact list of your cell phone, any contact you find you want to search, that item is available, your contact name is available, so the searching is successful, and the process return the location of that element. Otherwise, suppose item is not available inside your contact list in your cell phone, the search is called unsuccessful. So, successful is directly proportional to the when we found any item inside the memory, that is a successful case. If we do not found any item in a memory, that is called an unsuccessful case. So, there are two popular search methods that are widely used in order to search some item into the list. However, choice of the algorithm depends upon the arrangement of the list. The two approaches are called linear search and binary search. So, first we discuss about the linear search. We can perform this searching operation in any kind of data structure like array, linked list, stack, queue, trees, graph, any kind of a linked list we can use, and we find out we can perform all kind of operation, or especially a searching operation in all kind of data structure. Insertion part and deletion part already, and traversing part already we covered in the last tutorials. Today we focus on the searching part. So, linear search, we apply this linear search in a array. So, linear search is the simplest search algorithm and often called sequential search. I use keyword as sequential. Sequential means you put any pointer in some location at the either lower bound, either the upper bound. I will tell you briefly what is the role of a lower bound and upper bound, and the pointer will not skip any node during the operation. Suppose you are starting from the initial node and you having a 10 elements, and you search and you go through the last element, the location of the last element, that is called as sequential search. You can't skip any node during the operation, that is called as sequential search. In this type of searching, we can simply traverse the list completely and match each element of the list with the item whose location to be found. If the match found, then location of the item is returned. Otherwise, the algorithm return null. Linear search is mostly used to search an unordered list in which the items are not sorted. The algorithm of linear search is given as follows. By the example, we can understand how we perform the linear search. Here you can see linear search is a very simple search algorithm. In this type of search, a sequential search is made over all items. One by one, every time is checked, and if a match is found, then that particular item is returned. Otherwise, the search continues till the end of the data collection. By this example, we can understand. Here I taken one array and I already put some item inside the array, like that the first node containing the 10, second one is 20, 30, 40, 50, 60, 70, 80, 90, 100. The all node containing has some data, some values. So, I starting in a starting position, in the beginning position, where I put fix the value of 10. Here I indicating a fix a pointer, that is called a lower bound. This is the starting of any array, and up to the last position of the data element, that is called a 100. Here we put the upper bound. So, there are two addresses, that is called lower bound address and the upper bound address. Lower bound address is basically addressing the base address of any array. As we know that array is a static memory allocation. Before we designing array, we have to pass the value how many nodes we require to design that array, and the upper bound is not situated to the end of the node of that array. It would be hold the last element of the array. So, in this case, the lower bound will be fixed at the starting position, that is called first node. Here we having a item is 20, and the upper bound will be fixed at the last position of the data. Here the last element is 100. So, pointer are fixed, lower bound and upper bound, these are the addresses, and both are fixing at the address of the that particular node. Now, I use some pointer. I take PTR or I take any variable to cross check the item is available or not, the data is available, what we want to find out from the array, that is available or not. So, I fix that pointer. You can take PTR as a pointer, you take your name as a pointer, you take any variable as a pointer. So, either you fix at the lower bound, either you upper bound. There are only two locations where you fix your pointer in the linear array. You can't fix any mid of the position of the linear array. So, either you fix a lower bound or either upper bound. If you fixing the lower bound, so your pointer will be traversed from lower bound to the upper bound. In a vice versa, when you fix your pointer in a upper bound, that will be traveled from upper bound to the lower bound. Suppose you fix your pointer at the lower bound and you want to move that that pointer to the upper bound address, that will be incremented operation. And when you fix your pointer at the upper bound address, that is and move to the lower bound address, at that time you call the decrement operation. So, we can check how we can find out the item. Suppose here I fix one pointer, suppose I take a PTR I fix at the lower bound. 99% you have to put your pointer at the lower bound cases. That is really quite easy from traversing from lower bound to upper bound. You fix your pointer at the lower bound address, that is called a LB. You fix PTR. So, suppose I want to check, I want to find out the item is 50. So, I fix a pointer at the lower bound. I pass the instruction to cross check from my item to the data of value of the pointer. So, I check with the help of the conditions. If info of item equal to info of data equal to item, the condition is if is true, so location will be set it, otherwise pointer will be updated. Like that, in the first position, the information data of the first position is 10 and my item is 50. So, 10 is not equal to 50, info of PTR is equals to 10. That is not equal to the item 50. It means pointer will be updated if condition is false, but else condition is true, and during the else condition the pointer will be updated and move to the next position, that is called the next position. And here we are having a item is 20. Again 20 is not matching with the item 50. So, again pointer will be updated with the help of else condition. Now, pointer again updated, now holding the third position, here we having a item is 30. Now, again we cross check with the 50, now again item is not matching. So, our pointer will be updated with the help of the else operation. So, again pointer will be updated to the next position, is a sequentially moving the pointer from one location to the another location. So, next location is a fourth node, and here we having a item is 40. Again 40 is not matched with the 50 because here we having item is only 40. So, again pointer will be updated with the help of the else pointer. Now, the next node is 50. Now, next to the fifth node, here we having item is 50 and I want to find out the item is 50, the 50 will equal to 50, both are matched to each other. So, our searching operation is successful. This is a successful case. Suppose now, when we find out any item in my array, so look, I want to display, I have to display the address of that location. So, location will be fixed and display the address of that node in the linear array. This is successful. In a different case, suppose item is not available. Suppose I want to find out the 200 in this linear array. So, again I fix a pointer at the lower bound and I pass the instruction to continue to the upper bound. The upper bound value is 100, one by one, so by the comparing with all the data elements of each and every node, my pointer will be fixed at the upper bound by the travel from the lower bound to the upper bound. Now, upper bound, when we exceed, our pointer will be exceeded from the upper bound address, automatically loop will be terminated. So, when loop will be terminated, so item is not available. Suppose item is not available from lower bound to the upper bound range, it means item is not available inside the linear array. This position, this kind of situation is called the unsuccessful case. That's 200 value, 200 item is not available inside the linear array. So, here by this we can understand the operation of linear search animations. So, we can write the pseudo codes how we design the linear array. So, in a step 1 you have to fix the pointer at any location. I take one pointer that is called I. Again I told you, you take a PTR, you take a I, you take your name as a variable, any kind of variable you can take to as a pointer, and you have to fix that pointer at any location like a lower bound address or a upper bound address. Here I am fixing the lower bound address, okay, like that way, that is a 1. In a step 2, if I is, now apply the loop. If I is greater than n, then go to step number 7. Suppose I is a pointer and I will be exceeded to the last position, or we can say n is the nth number of element that is called holding the upper bound address. When I is exceeded from the upper bound address, then directly don't go to any step, then directly go to step number 7. In the step number 7, like in this way, step number 7 is print element is not found in the memory or in the linear array. Step 2, when you go to the step numbers, only on the single case when I is exceeded the upper bound address, that is the nth value of the linear array. If the condition is true, suppose I is less than n, it means go to step number 3. So, in a step number 3, here again I apply the condition. Now, I am here checking cross check our data value with the item. So, with this syntax, if a of I is equals to x, x is a searching item what we want to find out inside the memory. So, I write the index a of I, a means of any array and I should be passed at the inside the parenthesis. It means the when we write simple I, it's always pointing the address of the node. But when we call I inside the bracket, it means it shows the data of that pointer I, where I is pointed of any node, what is the data inside that node. So, a of I, it means the data value of that particular node, it's matching or not with the finding item that is called a x. If finding is successful, suppose a of I, it means the location of that pointer having a data is equals to the finding item x is matched, then directly go to step number 6. You can't follow the step number 4 and 5. So, directly go to step number 6. That is step number 6 is print element x found at index I and go to step number 8. Directly you can write this, your operation is successful, you can find out the x element at that particular address, at that particular index of I, and directly go to step number 8, and step number 8 is exit. But this is the if case. Suppose this condition is not true. If a of I doesn't match with your finding item that is called a x, then move to the step number 4. Now, pointer will be updated in step number 4, set I equal I to I plus 1. In a continuous form, we can sequentially update our pointer with the help of the increment pointer, that is order I equal to I plus 1. And by this we can go step number 5 and go to step number 2. Thus, the completely loop will be working from step number 2 to step number 5, when until and unless we don't find out any item inside any node. Suppose a of I is not matched with the x element, the continuous I pointer will be updated by the 1. In a single case, once any case, if we find out any item will be matched, to directly go to step number 6, otherwise go to step number 7. It means print element is not find out in the linear array, or we can write the unsuccessful case the location equal to null. So, this is the logic how we find out, or how we find out any location of the data inside the linear memory. This is a linear search. We can also write different type of algorithm about the linear search like that. Suppose in a step number 1, set the position equal to 0. Position means the location of that particular item, when we don't find out any item, that position is equals to 0 as remain or what we write in this step number 1. If location will be replaced by any address, it means the data value is available at that particular location of the node. So, step number 2, I set any pointer in a base address, or we can say the lower bound address. Here I set a I pointer at the lower bound address. In step number 3, I apply a loop, repeat step 4 while I is less than equal to n. So, n is the last position of the element and I situated at the first position of the particular, or we can say the base address of the array or the memory. Then step number 4, I apply a condition. If a of I is equals to value, or we can say item to be searched, if a of I is both are matched, so the operation is successful. If item is not matched with the item, it means we go for the next step. So, if a of I is equals to value, it means item is matched with the data of that position. So, I reset the position from 0 to that particular I location. So, directly print position. Here I want to display on the location of that particular I data what we find out inside the memory. If item is matched, directly we print the position, or we can say location to the location read in the display panel. Otherwise, go to step number next one, go to step number and then move to the step number 6, that is called the exit. Otherwise, you increment the pointer with the help of the I equal to I plus 1, and one by one we can travel from linear lower bound to the upper bound to find out any element. If the location will be find out, if the data item will be matched, so location will be reset, the position 0 to that particular location. Otherwise, step number 5, if you do not find out any item, suppose your contact list, that contact name is not available inside your memory, in a phone contact memory. So, the position after this performing searching operation, the position is remaining same as a 0. It means value is not present in the array, that is called the end of if structure. And finally, we can write the exit. So, this is a way, this is two kind of a approach, this is two kind of a algorithm to design a pseudo code for the linear search. So, the complexity of the algorithms are, there are basically two type of complexity, the time complexity and the space complexity. That three type of a variant of complexity are the best case, average case and the worst case. The three possibility of any cases, best case, average case and worst case. Suppose in a contact list, the alphabetical contact list will be stored in alphabetically order. Suppose you want to search any item with a start from the A, definitely that is a best case. Suppose you find out the which is the name of the letter starting from M, S, that is a middle average case. Suppose you find out the Z item, that is the worst case. So, that is a possibility of to searching any item inside the memory, either in the best case, average case and the worst case. Suppose you starting find out any item inside your class, during the class the student is available at the first bench. So, your searching is that is called the best case. When you starting and the student will be available at the mid of the position, that is called the average case, and student will perform all kind of searching operation and the student is available at the last student, that is called the worst case. So, that is a variants of the cases of when we finding out or the complexity of algorithm. So, time, the first complexity is time. Suppose you go and search any item and the first item what you want to find out, that is available at the first position, that is the best case, that is a O of 1. So, it is depend on the number of values, how many number of values are available, and the position first will be allocated the best case. So, that is it will directly reduce your time to searching an item from the memory. Average case, if you search, suppose you having 100 of items available in a contact list, and after the multiple time of searching operation, the location number 50 you find out the item, that is the average case, the O of n. Same the worst case, the item is available in the 100th case, the number of operations, number of searching operation will be executed the 100 times. After that you will get the item. So, the complexity, the time complexity it will take to to find out the item one by one till the last case, that is a O of n, that is a worst case of that. The average case and worst case both are same. It is the complete depend on number of items available inside the memory. Next complexity is space complexity. The space complexity is the only having a worst case, that is a O of 1. Best, there is no any space complexity of the best case or average case, and having only a worst case complexity, that is a O of n. That is the complexity of algorithm. So, by the programming we can understand how we can design a C program in a linear search. So, initially start use the header files of say include studio.h, then you use the void main functions. As if we know that main is a user defined function, void is why we write a void, there is no return data type. Always when compiler will be checking, I will find main is which kind of a data type. The main is a void type of data type, it means no return data type. Now, structure will be started. Here you take int a and inside the bracket parenthesis a 10 array of 10. So, as I told you, array is a static predefined memory allocation. You have to pass the how many nodes you required for the operations. You initially before you starting the operation, you have to pass the number of value inside the array, that is a 10. And after that you can statically you can write the all the values by the with the help of commas 10, 23, 40, 1, 2 like that. After that int is a data type. Here item, what we want to find out inside the array, and then next is another variable, that is I. I is a use for the pointer, and other is a flag. Flag is either a positive, either a negative. It means if flag is set, it means the operation is successful. If flag is not set, it means the operation is unsuccessful. So, printf enter items which is to be searched. After that one, so what we want to find out from the array, from any allocation from the memory, we have to pass that value inside with the help of printf and with the help of scanf. So, scanf, the percentage I want to find out the address of that particular item that is available inside the memory or not. So, I apply a loop, here I apply a for loop. So, you can use a while loop also, but by the for loop you can easily operate that operation for loop. So, inside the bracket you put the pointer I at the lower bound address, that is called as 0. The indexing value of the any array location is a 0 starting from. So, I is equals to 0. You apply the condition I is less than 10 and then is I plus plus. Again a structure will be started. If a of I equal to item is, it means the data of value of that particular a of I where I is pointed in the node, and the what is the data value of that particular node is matched with the item, it means flag will be set and break. You do not go the else operation. But if you apply a loop and I will be exceeded to the last address at the nth address, or we can say the 10th address. So, we do not go for the if operation, we go for the else operation. Else is a flag will be not set, flag as it is like a 0. So, if flag equals to 0, it means it is called a unsuccessful operation. So, you can write by the printf statement item, either you find at location, that flag will be set, else it means item is not found inside the memory. So, you can write both cases, either if or else. If condition is true, you can write item found at location, the flag will be setted, else item is not found, flag will be not setted. This is we can write the C programming of the linear search. So, the output, suppose you want to search a 20 item in the linear in a linear array. So, 20 is available in which location? If item is found, so here 20 is not found because 23 is available. So, item is not found. Enter item which is to be searched. Suppose you first you search a 20 is not available in that memory, it means item not found, the search is unsuccessful. Suppose in the next case you want to search a 23, that 23 item is available inside the memory. So, here the operation is successful, item found at the location of 2. You can display the location or the address of that particular node where you find out that particular item inside the memory. So, you can display the address of that particular node. So, this is how we can write item is found or not found. So, this is a way to find any item inside the memory. Now move on the second operation, the second type of search, that is called a binary search. The little bit difference between the linear search and binary search. Binary search are little bit better than the linear search. Why? Binary search is the search technique which works efficiently on the stored list. Hence, in order to search an elements into some list by using binary search technique, we must ensure that the list is sorted. The condition is applied. In a linear search, you don't require to item will be either sorted or not sorted, but in a binary search it should be, it's mandatory, your item should be in a sorted way. As I told you, sorted is a technique to arrange your data either in ascending order or in a descending order. Data will be organized way, in a sorted way, in a ascending way, then we apply a binary search. In a linear search that is not a compulsory, but in a binary search it is a mandatory, data will be sorted. If data is sorted, then binary search will be applicable, otherwise binary search is not applicable. So, binary search follows divide and conquer approach, in which the list is divided into two halves and the item is compared with the middle element of the list. If the match is found, then the location of middle element is returned. Otherwise, we search into either in a half depending upon the result produced through the match. So, either you search your item in a bottom half or either you search in an item in a upper half. That is complete depend on this situation, the value of the data of the mid. If we compare the data value of the mid with the item, if both are matched, if the operation is successful, but if doesn't match, so you can compare your item either in a range from the lower bound to the middle one or either from middle one to the upper bound. This depend on this situation. We can check how we check that one. So, binary search algorithm we can understand by this example. Let us take one example. Let us consider one array, and in array we having some elements like 1, 5, 7, 8, 13, 19, 20, 23, 29. So, find out the location of the item 23 in the array. So, these values are already stored in one node, like 1 is stored in the first address, 5 is another address, 7 is another address in a continuous form. So, lower bound address containing the value of 1 and the upper bound address containing the value of 29. In that way, in step number 1, you have to set the pointers. So, you initialize the big pointer and the end pointer. Big means beginning of the pointer. Beginning will be holding the lower bound address and the end pointer will be holding the upper bound address. And you set one another pointer that is called a mid. Mid is depend on the formula of like that integer inside the bracket beginning plus end by 2. So, again I repeat, mid is the formula of mid equal to integer inside the bracket beginning plus end by 2. So, in step number 1 you fix all the pointer. Now, move to the step number 2. In a step number 2 you find out the position of the middle by the formula of that one was I told you in earlier. So, if your data will be matched, your item will be matched with the mid value. So, beginning plus end by 2 integer. If your value is like 4.5, so you will take only a 4. So, imaginary number only take your real numbers, not take a imaginary number. So, and mid will be set at the 4. So, like that they will take a beginning is 0 and the end position is 9. So, 9 divided by 2 it means 4.5. You can take only mid value as a mid position as a 4. So, again compare, you can compare that mid value with your item. If data is matched, so it means your location will be successful, otherwise you change your pointers. Suppose here I want to check a 23 data of mid equal to here beginning equal to that pointer and the mid value that one. So, mid equal to 6. So, A of mid equal to A of 6, 20 is less than 23. Therefore, we reset our pointer beginning equal to mid plus 1. By this one, if your pointer mid value will be set at the mid position of the big end during the big end and the value will be matched, otherwise your pointer will be set. Suppose your pointer will be greater than the mid value, reset your pointer beginning with the help of mid plus 1. If the finding mid data is greater than the item value, you can reset the end pointer with the help of mid minus 1, that is called end equal to mid minus 1. So, again you cross check the same process from beginning. Suppose the value item is less than the data of mid, so the end pointer will be reset, and data is value is greater than the mid, your big pointer will be reset and operation will be same as it is what we discussed in the previous one. This portion is continuously until we do not find out the value of particular item, the data of mid. If data of mid equal to item, it means the operation is successful, otherwise the process is going on till the beginning is cross the ending operation. If beginning is cross the ending pointer, either ending will be cross the beginning pointer, the operation is automatically terminated and the operation is unsuccessful. So, by this we can write the successful case and the unsuccessful case. So, by the pseudocode we can write set the beginning at the lower bound, end will be upper bound, then repeat step number 2, repeat step here we apply a loop, repeat step 3 and 4 while beginning is less than or equal to end. In step 3, set mid equal to integer beginning plus end by 2. In step number 4, here we apply a condition, if a of mid equal to value, set position equal to mid, otherwise and also write print the position, or we can say print the location, and go to step number 6. Otherwise, or we can say else if data of mid is greater than value, set and equal to mid minus 1, else set equal to beginning equal to mid plus 1. It is completely depend on the situation, what is the value of mid and what is the value of item. So, end of if structure, end of loop, and step number 5, if position equal to minus 1, it means print value is not present in the array. Suppose one of the pointer beginning will be exceeded from the end pointer and position, it means your item is not available inside the linear array. But this is the operation how we can perform in a binary search, and the last one is the exit. So is the complexity of this algorithms are performance and complexity. So, the worst case having a O of log n, best case O of 1, average case O of log n, worst case O of n. This is the complexity of this binary search. So, we can we have also discussed the C programming, how we can write our C program codes. So, initially you write down the header file, then int binary search, int, how many variable you want to require, then use a void main, you pass inside the array as what we discussed in the linear search, the same array, pass the value of array, put all the values, then you find out int item, then location equal to -1. If item is not found, so location will be not changed. If item is found, location will be changed. So, by the printf statement, enter the item which you want to search, then a scanf, you have to find out the location of that particular item. If location equal to binary search from array 0 to 09 item. So, if location is unsuccessful, if location is successful, then write print item found at location and write out the address of that location, else print item not found. Int binary search, same parameters inside this structure, int of mid, if and is greater than or equal to big, this is the range what we want to follow. Inside this structure, we have to find out the value of mid. We can find out mid equal to integer big plus end by 2. If a of mid equal to item, then return the location. Otherwise, you have again you cross check the same process, either a of mid is less than of item, return binary search a of mid plus 1 comma end comma item in a bottom case, else item should be available in the either in upper case like a return binary search a beginning, and beginning will be reset to the mid minus 1 and item. and I write down the return -1. So, this is the output. Enter the searching item which you want to search, suppose is a 19, and item found at the location is 2, is the bottom half of the binary search. So, this is a today we discussed linear search and binary search. This is a searching algorithm. So, I hope you can understand both topic in this tutorial. Thank you.